Right, hello everyone. I'm Professor Caudill. Right, and today we are still doing motion, so we got a lot of good code written last time. Maybe we can check out this bicycle as 10. So B not B is 0. So the runner. Okay, so the runner. So V not of the runner starts at 0. T is 30 seconds. So we want to find A. We'd say not. So what are we solving for? We're solving for A, and we're probably going to set some functions equals to each other. Okay. So I think it would be helpful if I had this below T x not equals. Not sure how we would write V average. Would that just be the absolute value of V? No. All right. I want to write region 1 is I just want to make these like in latex because in latex. X is equal to x0 plus V average. What do we want to use for V average? Maybe we can just use V prime. Okay, they don't let me do that. V star. Okay. Symbols. Okay, V. V average, V alpha. Okay. V average. Okay. I like that a little bit more. And V that over 2. So it's 2 and display. Okay, so we're making progress. V average. Okay. Now I know there is a way to make like the line above the symbol. It's just like I don't want to spend too much time in simplify. How do I make a symbol with a line above it? Okay, we'll try this one. What's going on here? Okay, it gave me a check mark. It's kind of weird. There we go. Okay. I guess wasn't as hard as I thought. All right. V equation 3 is equation 3. X is x naught plus v naught times t plus 1/2 times a times t squared. That's very weird. Display 3. Oh, I see. That would help. There we go. Okay, almost done. Um, okay, next one is x is. Okay, I think we skipped one, did we? Equation 4, equation 5. So we got x, v average, v, okay. It's here. V is v naught plus a times t. And v squared is v naught squared plus 2 times a times x minus x naught. Okay, and maybe I can number them. Okay, so we have equation 1. I don't know if I like that. Let me double check before I delete this. X naught plus V average times T. V average equals V naught plus V divided by 2. V is V naught plus A times T. X naught plus V naught times T plus 1/2 times A. I guess I can just be safe. 1/2 times A times T squared. V squared is A V naught plus 2 times A. Mm, okay. So we want to use these equations to solve this. So we're going to get two. We're going to take two of these equations. And we want to see how fast the runner catches up to the bicycle. Okay. So what do we know? We know V naught for the runner. We know V naught for the bicycle. Okay. So we can probably calculate. That's right. V naught. Oh, that is right, I guess. Okay. So do we find average velocity? V naught. Okay, so V is final velocity. Um, I don't know if we need average velocity. This. I think we want to find X for sure. So maybe we do want V naught. Okay. We want to find how much it's accelerating as well. Bicycle's constant. Okay. So we know X naught as well. So that's for both people. For the bike, X naught of the runner, 0. So we want to know how fast the runner needs to accelerate to catch up the bike. The bike is 0. It's constant velocity. Okay. So I think we need to look at isolating x. So we want to set x equals to x. So bicycle's going the same in the beginning of n. So we can say v of the bike is going to be 10 plus 10 over 2 equals 10 meters a second. Okay, so therefore x is 10, 30 seconds plus 0. So the bike's going 300 meters in 30 seconds. And so this 10 is a meters per second, so the seconds will cancel out. That matters. Okay, so now we have x. So we want to find when 300 meters is equal to 0.5 a 30 squared plus 30 b naught. Zero. Okay, plus 0. All right. So this is 900. 900. So minus 600. So minus 300 equals the acceleration. Which doesn't make too much sense. So let's see what the book does. And it doesn't say. Okay, V. Okay, so we used, they use a different, we use average velocity, they use that. Okay, so it's saying we should have used this one instead of this one. Okay. So, the final velocity, I think this is of the bicycle, equals a constant times t. Maybe it's for the person, for the runner. It would be you'd have to be running the same velocity as the bike at the end. So I'm gonna say v. It's 10 a 30 plus 0. So acceleration should be 1/3. Maybe that's what the book got. Okay, 1/3 meters per second. I'm guessing the more we are trying to, like, it's kind of like riding a bicycle. When, like, using these equations, the more you ride, the more you try to frame problems into fitting into one or more of the equations. You'll recognize it faster the more you do it. Free fall, so this is a y, gravity to analyze free fall. Alright, so we're talking about gravity. Important concept. Basically, everything is attracted to the center of an object. All bodies have a pull inward. Okay, so on the moon, there's no gravity, so all objects fall at the same pace. Um, there's barely any. So we have air resistance, so they don't drop in a vacuum. So these chapters we're gonna assume in a vacuum. That'll probably make the math a lot easier because you think if you make the math in a vacuum, then it's more accurate. It's more generalizable. Force gravity, objects fall towards the center of the Earth. So this is the important constant of the day. Gravity is 9.81 meters per second squared. So it's a constant. So we can use our simple kinematic equations. So we're going to use 9.8. All right. Okay, so this is important. If we define upward direction, then A equals negative. Then gravity is accelerating down, negative 9.8. But if down is positive, then A equals 9.8. I think that's what it's saying. That's kind of confusing. Well, hopefully we have some examples to clarify. One-dimensional motion involving gravity. Simplest situation. All right, so what's the simplest situation? Straight up, down motion. Okay. Okay, so we have an object and we're going to drop it. Then v naught equals 0. Where the object has a left contact. Okay. So t greater than okay. TF equals no longer free fall. So they're just going to replace A with G. And they replace Y with that. So shouldn't, I mean, you understand it, you understand it, you know? I don't think we need to change these. So deciding on the sign is part of the strategy. So in these, acceleration is negative. Okay, so we're going to use negative. Some problems we used to have acceleration positive. Record the unknowns, draw sketches. Okay, decide which are to be used. So draw it, write the unknowns. Figure. Okay, so we have a picture already drawn. We can go ahead and write our knowns. That is thrown from height. So our y naught is 98 meters. And we know gravity is negative 9.8 meters per second. So we want to know, so find y and v of y. Okay, so what are we going to do? First, we're going to find y. So we know does it say how much time? 4 seconds. Okay, so I'm guessing we use the fourth equation. So y is negative 9.8 times 30. No, 4 over 2 plus 4.9 plus 98. So you notice this should be a t squared. So that gives a second squared, and that means the second squared in the acceleration cancels out. So the final unit will be in meters. So we can just do solve equation 4. Substitute x for substitute a for negative 9.8. Can I do that? Haven't. Okay. Dot substitute T, T for 4. Dot substitute B naught, no, Y naught for 98. Okay. 1. And 4.9 is V naught. 4.9. Substitute V naught for 4. So 39 meters, 39.2. So if that's right. 49. Okay, so what did we mess up? Okay, so negative 98 plus that. Maybe can we just write I think this was wrong anyway. 9.8 negative 4.9 T negative 4.9 negative 4.9. Okay, there we go. Still not quite right. So we're solving for T, right? T is 4. Is T 4? Maybe if I take this out. Okay. I don't know if that's right either. Minus 20. Hmm. Negative 9.8. 0. Okay, so maybe we should make x naught. This should be x not be 0. Should y not be 0? Y naught is 0. Looks like. Okay, I think I see what's going on. So x is 98. And then x naught is 0. Minus 4.9t. Minus 4.9t. Minus 4.9t. Okay. Got it. So I think that's kind of correct. Now we can solve it, and we get 2. That's kind of weird. All right, so let's take let's take 8 divided by 20. So we're going to get 20 equals t squared minus t. So we want to solve this for t. So do I write solve this for t? I guess I don't need to write t. I'm not sure. I think I'm missing. I think one of these numbers should be positive. That's why we're getting negative 20 t. So this t is plus. This is a plus t here. So where are they getting the plus t? 9.8. So they're making it's 9.8. Okay, that's positive. No, they're making this negative 9.8. So it's a negative 9.8. Then it's 5 and 4. That's a headache. Positive root is what we want. Okay. So now we know what else did we want to know? We wanted to know velocity. It arrives at the ground. So we want the velocity after 4 seconds. Okay, velocity after 4 seconds. Um, I don't know if this will work, but we'll try it. V not. So X, A. Okay, so none of this is getting. Say XX. Um, Subset A. Okay. That that right there is beautiful. Beautiful. So I can just take the function, I take the knowns, and it just solves it for me. Um, all right, awesome. So what's V after 4 seconds? V after 4 seconds. We know the acceleration time. So we're going to use V equals AT plus V naught. Okay, so now we want to define another function. I want to use function 3 now. I want to solve equation 3. Okay, so I'll do function 3. I want to do X. I want to solve for V, so I want to solve for V, and I'm given no X. We can take this out, right? Uh, VV. Okay. So V is VV. A is AA. T, TT, and V naught. Okay, so this one has 4, and we're going to give you nothing for V. I'll give you a T, and I'll give you an A. A is negative 9.8. Give you a T for 4 seconds, and I'll give you initial velocity. -4.9. So I'm getting negative 34.4. So negative GT, negative GT. Seems right. 9.8 for 4.9, right? 9.8 for 4.9. Negative 4.9. Negative 4.9. Negative 44. Okay, there we go. The functions are working. It's just like, the only hard part is getting the signs right. The hard part is getting the signs right. So otherwise, very satisfied with this method. So place BB with givens given I change this to G, still 9.8. Okay. Gravity. So X meters. So shouldn't this be a Y meters? Y meters? Gravity where starting with free fall at from origin XY graph. I think that makes sense. So we're starting at so gravity at so everything after that. So we start at 0 and then we're just going down. Velocity is going down. Okay. Okay. Okay, we got another example. So Batter hits a baseball upwards. Upwards. I think that's keyword, upward. So we're going up. It's caught after 5 seconds. So find the initial velocity, maximum height of the ball. Okay. So I guess we can just start by finding velocity. So we know gravity, but this time gravity is going to be positive because this is a positive y. Okay, so what do we know? We know that. So we're probably going to use, we want to find V naught. Do we know V naught, V naught, V naught, V naught? It's gotta be this one, right? So we know, do we know the final velocity? When it's caught, it's gotta be 0, right? All right. We'll try. We'll try that. So I'm gonna use function 3. BVAA T V0. So actually we're just gonna use function 3. Yep. So we've already got function 3. So function 3, we're gonna say V, the final V is 0. We're gonna use positive gravity. Hmm. Um, all right. So we 0. V naught is V naught. We don't know V naught, but we know we know T. T is 5 seconds. V naught, we don't know. I'm getting 49. Is it 49? 36, 36. And they're using a different equation. They're using, they know the y naught 0. So y naught is 0, so we're going to change this to 4. So we know it's 0. G5, V x naught is 0. So we get 24. And they're using, where's this -2 coming from? Are they using negative gravity? It's not mattering. Um, they're getting 24.5 here. They're using equation 5 here. Okay, it's 24.5. That's it. Then they're going to the next questions. Okay, I got it. So with 24.5, they plug it into equation 5. So we haven't built that one yet. So function 5. So I can put this function as a so we can do function 5. It's going to be b naught x naught. Okay, about out of time. So what did they plug in? 0, 24, 0. Okay, so it's 0. Final velocity is 0. They're doing negative gravity, negative g. Maybe that's better. Okay, negative g. Time is 5. And then x naught. Okay, I messed this up. V A X V B V A X X naught X naught and V naught. So the order should be 0, gravity, X is what did they choose for Y? Y is, so they're solving for Y here, but why not 0? So we're solving for X in this equation. And we know X naught. Do we know X naught? X naught is 0. Okay. 0, that. Uh, T is not defined. T is not defined. Okay, 4.9 T. I see. I see what it's doing here. This is getting read as a different thing. So display this 24. So we're gonna say okay. We'll have to work on this some more. But in theory, we should just be able to put function 4 into function 5 without having to calculate it. But all right, thank you guys for hanging out. I'll see you next time.